our next chapter is Laplace transform, right? So what is Laplace transform? Okay, remember in our chapter 1 and chapter 2, we have done with identify the first order, right? Second order, we identify the types of the differential equation. There are many methods in solving the differential equation. Okay, so we have in our previous chapter, in chapter 2, we have done with homogeneous, non-homogeneous, second order, third order, fourth order, and so on. Okay, so that one is solve the differential equation directly from the given problem. Okay, you have a problem, that problem is in the term of differential equation, then you solve the problem. So that is what we did, okay, in our previous chapter. Okay, so now for this chapter, still we are going to use the Laplace transform here in order to solve the differential equation. Okay, still we are going to focus on differential equation, but what if that kind of differential equation is quite complicated to directly solve by using the methods that you have done previously? Okay, all right. So we apply the transformation to that differential equation in order to ease the process of finding the solution. So the differential equation, okay, you know that this is the differential equation where we have a function in terms of x, y prime, y double prime, y prime t, f t, and so on. Okay, so in this Laplace transform, we are going to transform a function, let's say in terms of t domain here, time domain here, to another domain of, let's say it is in terms of s. Okay, we are going to transform by using Laplace transform in order to change the domain of the original problem. So your original problem may be in terms of ft. After we transform, we are going to have a function in terms of s domain. So this transformation is used in order to solve the complicated differential equation or to solve the differential equation in another domain. Okay, so there are many transformation, okay, such as Laplace, Fourier, Z, and so on, many more. But we are going to focus on Laplace. Okay, so what is transformation here? We just transform a differential equation to a function of another domain, which is S domain here. Okay, once after you transform, then what? Then you need to solve the function in the S domain in terms of Laplace transform. Okay, you have differential equation, you transform to another domain, and then you solve the function in another domain. And then you apply the inverse transformation to get the solution in the original domain. So let's say we start with the T domain, we transform to get S, we solve for S, and then we inverse transform to get the original solution in the original domain. So what we did in chapter 1 and chapter 2 is you have differential equation, then you solve. That is the process that we have learned previously. We have a problem, then we solve. Okay, but in terms of transformation, we have the differential equation, we transform, we find the solution of the transform version, we inverse transform to get the solution of our original problem. Is that clear? So this is the overview of why you have to know about this transformation, about this Laplace transform. Is that clear, everyone? Okay. All right, thank you for the response. Okay, now this is the overview of the chapter. Now let's take a look. What are the topics that we're going to learn? Of course, we are going to learn about the definition, the basic of Laplace. And then we are going to learn the properties of Laplace. Okay, once you identify the properties, we are to transform some sort of special function, okay, which are unit step function and direct delta function. And then once you can transform, then you need to know how to inverse transform. Okay, and once you know how to transform and inverse transform, Then we can solve the differential equation of IVP and BVP by using Laplace. We can solve the system of differential equation also by using Laplace. So these are our objective. We want to solve the differential equation, but by using the transformation first. Okay? So now let's take a look. Let's take a look at the definition of Laplace. Okay, can you see the screen here?
Yes,
Okay. This is the definition of Laplace. Okay, so the Laplace transform is defined by this. Okay, how can you transform the Laplace transform? If you have ft, okay, you transform by using Laplace transform to get fs. Okay, this is how you transform. So Laplace transform of ft is given by fs is defined by integrate from 0 to infinity exponent minus st multiplied by ft and then integrate this with respect to t. Okay. Now, okay, let's take a look. You have your function. You have your function ft equals to a. You want to find fs. So Laplace transform ft will give you fs. How to transform? Integrate from 0 to infinity exponent minus st times with ft. And your ft is a. So substitute a here. Then a here is a constant. Put a outside. Integrate exponent minus st. Then you will have exponent minus st over minus s. Apply the limit from 0 to infinity and then you get a over s. This is your fs. So this is how you obtain ft equals to a to fs equals to a over s. Okay. In order to transform a constant, you will get a over s. So basically, from the table of transformation, this is directly from the notes. From the table of transformation, if your ft equals to constant a, then your fs is a over s. If your ft equals to 5, then Laplace transform 5 becomes 5 over s. If your ft is equals to exponent, because exponent is a constant, then your fs should be exponent over s. If your ft equals to a, then your fs equals to a over s. Is that clear? This one, if ft is equals to 7, then fs is 7 over s. Okay, so this is how you integrate. Okay, exponent minus st, this one, bring it downside. Then simplify minus 1 minus a over s, put it outside. So 1 over exponent st, substitute t from infinity to 0. So 1 over infinity is 0, 1 over 1 is 1. Then you get a over s here. Okay, clear now for the first definition. Anyone has question? Understand or not?
yes, sir.
Okay. All right. So this is a constant. Now we have exponent to the power of at. Okay. So if your function is exponent to the power of at, by definition, if you want to transform, okay, Laplace transform of ft will give you fs, where fs equals to integrate from 0 to infinity exponent minus st times with ft. Now ft is exponent at, so just put exponent at here. Okay, then simplify. So you integrate this, you simplify, you factorize here. Okay, this one is just an integration process, right? This one is minus s minus a. Here, put it outside as a constant because there is no t involved there. Then this one is negative, just put it as a denominator. Okay, and substitute the limit from 0 to infinity, and you will have fs equals to 1 over s minus a. So as you can see from the table, if your ft is exponent to the power of at, you will have 1 over s minus a. So if you want to transform exponent to t, then you will have 1 over s minus 2. If you have exponent negative 2t, then you will have 1 over s minus minus 2 should be 1 over s plus 2. So this is how you transform of exponent. Okay, basically this is how you transform by using definition, apply the definition, okay, multiply with exponent minus st and apply the limit. Okay, basically the table here is obtained by the definition. Clear? This one, if you have exponent 3t, then you will have 1 over s minus 3. Exponent minus 3t, 1 over s plus 3. Okay, understand or not? This is new for you, right? If you have problem, you can ask. Or you have learned this previously.
New data.
Okay, anyone has question? All good? Understand it all? All right, so that one is for constant, another one is exponent 80. Okay, we will face all of the functional type of function here in the table through our example. Okay, so now why? We already have the table. Why we have to apply the definition? Okay, because you need to understand. Because sometimes your function is in terms of a piecewise function. Okay, where you cannot directly transform this based on the table. So how can you transform? Okay, now when you have a piecewise function, as you can see, a piecewise function has range for each of the function given. So now, by definition, this is your ft. By definition, if you want to have Laplace transform of ft to get fs, you need to integrate from 0 to infinity exponent minus st times with ft. And your ft has 3 types of function. So From 0 to 5, it involves only 2. So multiply exponent minus st with 2, but only from 0 to 5. Okay, and then from 5 to 10, exponent minus st times with 0. And from 10 to infinity, exponent minus st times with exponent 40. So the range from 0 to infinity now start from here and stop at here. So still we integrate from 0 to infinity of exponent minus st times with ft. But it is now divided to 3 parts. So you need to integrate this one by one. You cannot use table for this case because the table here is only from 0 to infinity exponent minus st times with ft directly. Okay, such a simple function. But for this one, you need to obey with the range given. Okay, try to integrate this. Any question? Understand or not? Okay, try. So the middle one here is multiply with 0, so no need. Just integrate the first one and the last one. Okay, anyone has problem? Okay, good. Not so far. All right. So now integrate this will give you minus 2 over 5 exponent minus 5s minus 1 because of 0 there. Okay, and then this one is 0. This one, same with the previous one on how you integrate, but with a different limits here. Okay, try to get the answer here. If you have problem, please ask. Okay. All right, everyone got this? Okay, so I believe all of you got this. Okay, now that is how you transform by definition. Okay, I'm not going to show you one by one of this table later. Through the example, we are going to face certain types of function according to the table here. Okay, so basically Now you know how to transform by using definition. Just integrate, multiply with exponent minus st there. So that is how you transform. Basically, based on the definition, or else you can refer to the table directly. Okay, so sometimes by using definition, you may use this definition to prove on something. Okay, or you are asked to transform by definition so you know how to use it. Right? Okay, now let's proceed. By the properties. Okay, so here, the first one, there are properties. Okay, now you know how to transform by using definition. Okay, once you know how to transform, you need to understand the properties of transformation. Okay, in order for you to ease the process of transformation. Okay, so the first property is the linearity property. Okay, where this linearity property involve addition, subtraction, and also scalar multiplication. So addition and subtraction, scalar multiplication. So how? So let's take a look at this. Now you have 1 plus 5 exponent to the power of 40 minus 6 sine 2t. You need to transform this. So by linearity, you can transform one by one because you can just separate 1, 5 exponent 40 and also 6 sine 2t. So you can transform this one by one. So Laplace transform of 1 will give you 1 over s. So 1 over s. Laplace transform of 5e40. So this is scalar multiplication of c. Then put that 5 outside. So you just focus on transform this exponent 40. This exponent 40 can be transformed directly based on the table of transformation. Exponent 40 will give you 1 over s minus 4. So 1 over s minus 4, then multiply with 5 outside, will give you 5 over s minus 4. Okay. Then, that one is the second part here. The third part, this is 6. This is 6. Scalar multiplication, put 6 outside. Okay, so you focus on transforming this. So sine 2t, sine 2t, sine 80. So if you have sine 80, the transformation becomes a over s squared plus a squared. Now you have sine 60. So a is 6. A here is 6. So you will have a is 6 over s squared plus 6 squared. Will give you, 2. A here is 2. So 2 over s squared plus a squared. So sine 80 equals to a over s squared plus a squared. So a is 2, then this one is also 2. Next, once you obtain the transformation version of sine 2t, then just multiply it with 6 outside. So we'll give you 12 over s squared plus 4. Why minus? Because this is minus. Okay, clear? So this is how you implement the linearity property by separately transform one by one. And if you have a scalar multiplication, put that scalar outside. Okay, clear?
Clear, Doctor.
All right. Okay, next. All right, so today let's focus on this. Now you know how to transform by definition and also by looking at the table of transformation. And we have learned properties. We have linearity, first shifting property, and multiplication. So after this, we're going to have another properties, but let's just focus on these three first for today. Okay, so now the next property is first shifting property. Okay, so you know that when you have ft, okay, when you have ft, if you want to transform ft, you will get fs. So by shifting property, okay, by shifting property, if you have that ft multiplied with exponent to the power of at, it will become fs minus a. Instead of the original one, you have ft, you transform to get fs. Now, if that ft is multiplied by exponent at, by first shifting property, the transformation becomes fs minus a. Okay, let's prove this. Okay, so now, if you have ft, right? If you have ft, the transformation of fs will give you integrate from 0 to infinity exponent minus st times with ft, right? So now this ft is a EATFT. Okay, so exponent minus st multiplied with st here now is multiplied by EATFT because of this form. Okay, so then we just simplify exponent, exponent. Then you just can add the index. So simplify it here. And then this is ft. So let s minus a equals to r. So if s minus a here equals to r, okay, then it will become exponent minus to the power, exponent to the power minus rt ft, which is equals to fr. Why? When you have exponent minus st ft, you will have fs. Now, exponent minus r ft, you will have fr. And you know r is s minus a. So that's why f s minus a. So that's why when you transform EATFT, the transformation becomes fs minus a. Is that clear? Anyone has question? Okay, so this is the proving process of where does this fs minus a come. So now how can we apply this property to solve a problem of transformation? Okay, let's try. Let's try to get the answer here, 1 over s minus 2. Right. Okay, now looking at the first shifting property, if you have exponent ATFT, the transformation becomes fs minus a. So now you have e to t times t. You know that your a equals to what? Your ft equals to what? What is your a? According to the general form of first shifting property here. So your a equals to this one. Right, this is a. This is a. So a equals to 2. Right? Okay, then your ft equals to t. Okay, when your ft equals to t, then you can have your fs by transform ft. So transform t, you get what as your fs? Okay, looking at the table of transformation, you have here t to the power of n. Okay, if your ft equals to t to the power of n, the transform version of fs becomes n factorial over s to the power of n plus 1. Okay, so now your ft equals to t. So if the function is in terms of t to the power of n, your fs is n factorial over Sn plus 1. So t here to the power of 1. So fs become what? N here is 1 factorial over s to the power of 1 plus 1 will give you 1 over s squared. So this is your fs. So if fs equals to 1 over s squared, then fs minus a equals to 1 over s minus a, where a is 2. That's why transform e to t equals to 1 over s minus 2 squared. Is that clear? Anyone has question? Okay, clear? All right, try example 5 here. This one, try example 5. E for t cos t. Done. 1 over s minus 3. Are you sure? Because a here is 4. A itself is 4, right? Okay, let's see. Let's see this one. From here, you know that your a is 4. Okay, your a is 4. This is your a. That a is 4. And your ft is cos t. Your ft is cos t. So refer to the table. When your function is cos t, cos at is s over s squared plus a squared. So since cos t, a equals to 1. So cos t become s over s squared plus 1. So this is fs from cos t. Now, from this fs, you want to have fs minus a. So just use a here. Every s in the function just minus with a. S become s minus 4. S squared become s minus 4 squared plus 1. Okay, clear now? All right, okay. Let's proceed. Can we? Okay. So another property for today is linearity dan first shifting multiplication by t to the power of n. Alright, so how? Okay. So in multiplication by t to the power of n, okay, the function is in terms of t times ft, t to the power of n times with f. So in first shifting, we have what? We have exponent at times ft. Now, multiplication by tn is given by where you have a function combined with t to the power of n. Okay, then how can we transform? By using this minus 1 to the power of n dnf dsf. Means you need to differentiate the fs that you have taken. Okay, let's take a look at the example here. Okay, you have t sine 60, where you know that from here, you know that this t is to the power of 1. That's why n equals to 1. Okay. Now, ft equals to sine t. So when ft equals to 6 sine 60, then fs equals to 6 over s squared plus 36. How? From the table of transformation. So this is your fs. And you know that if we want to transform t sine 60, it will become minus 1 to the power of n, where n equals to 1, and differentiate f with respect to s. So, minus 1, differentiate fs here, 6 over s squared plus 36. Then you have this. Okay, clear now? Just multiply with the product of differentiation. Once you differentiate, this is your obtained function, then just multiply minus 1 to the power of 1, then you get this. Okay, try it. All right, so now let's take a look at the last example for today. So, as you can see from here, it is exponent minus t sine 2t. So, what are the properties involved here? 3, no, shifting and multiplication. Okay, so either you want to rearrange this one as t exponent minus t sine 2t, okay, or you want to remain the original arrangement as exponent minus t sine 2t. Okay, so it involves shifting and multiplication. Okay, you have two types of solution here. This one is Tn Ft, where this is your Ft, this is your Tn, or by shifting, this is exponent At, this is your Ft, right? This is your Ft, this is your exponent At, and from this Ft, it is what? It is another property. Okay, this Ft is in terms of exponent At Ft, and this Ft is in terms of Tn Ft. Okay, so how can we do it? Right? So just use one. Okay, let's try this one, the original arrangement. Okay, so as you can see from the question, since this is EAT, this is FT, okay, you know that your A equals to, what is your A? Yes, A equals to minus 1. And Ft equals to T sine 2T. Okay, you know that since this is mapped to EATFT, then the Fs equals to Fs minus A, right? So you have to have your Fs. Okay, so now in order to find Fs from this Ft, you know that this Ft use Tn, multiplication by Tn property. So you need to understand what is your n. So your n here equals to 1. And what is your Ft? Another Ft lah. So what is your Ft here? Sine 2t. What is your Fs here? 2 over s squared plus 4. Then the transformation, then the transform of t sine 2t becomes minus 1 to the power of n equals to 1. Differentiate dn d, differentiate dnf, which means differentiate it once, where f equals to what? F equals to 2 over s squared plus 4. Okay, we'll give you what? This one is minus 1. Minus 2 to s. Two over s squared plus 4. Minus 4s. S squared plus 4. Minus 2. So become minus 1. This one is minus 4s over s squared plus 4. So you have 4s, s squared plus 4 squared. So this is your transform version of t sine 2t. So this is your Fs. Now your A is minus 1. Okay. So A is minus 1. Sorry. A is minus 1. Fs equals to 4s over s squared plus 4 squared. Then Fs minus A becomes 4s plus 1. S plus 1 squared plus 4 squared. Alright? This is how you do it. Okay, so you can change. You can change the variable here. Maybe this one is Z. Okay. Then your Fs is 1. All right, clear or not? Anyone has question? Try to understand first. All right, anyone has problem? No problem. Okay, and everyone understand? Right, so I hope you can proceed with the tutorial. Okay. So if you have no problem, I think you can stop here today because in our next topic, we're going to proceed with the next property. So I hope you can try to do the tutorial first, right? To have better understanding on the topics that we discussed today. So no more problem. All of you can understand this. All right, good. Okay, so let me stop the recording first. So far, so good. Okay, good.